Hey everyone, Mr. Cohen here. So today I'm going to walk you guys through how to write and name different chemical compounds. Now, this is actually going to happen in the next series of videos that you guys are going to be watching. But make sure you pay attention and nope. Hey everyone, Mr. Cohen here. So I'm going to be walking you guys through how to write and name different chemical compounds. Now we're going to be doing this throughout the next few videos together, and I'm going to show you guys a few strategies that you can use to figure out the right number of each type of atom you need and how to write the chemical formula and all of that cool stuff. Now stick with me, you're going to want to take some notes here, and always beware because there might be questions that pop up, sort of like this. Now that you've answered that really tough question, we're going to take a look at the difference between writing and naming a chemical formula. There is a difference. Those are two different things. It turns out that writing a chemical formula is what you would actually write down on a piece of paper. That includes the actual chemical symbols, or the element symbols. So for example, NaCl is the written formula for salt, sodium chloride, or K2S is the written form of potassium sulfide. Naming a chemical formula is what you would actually say to a friend. So you wouldn't say to somebody, hey, go get the NaCl or the K2S or the CuSO4.6H2O. Like, wow, that is a lot to talk. So instead we have names for these things that we actually say out loud. So we write them and name them, and those are two different things. The naming is what you would actually say, whereas the writing is what you would write down on a piece of paper with the actual element symbols. So we're going to use a couple of different strategies to figure out how to write the chemical formulas, and that's probably the hardest thing, because it's not always clear how to write a chemical formula, especially because if you're given two elements, you don't necessarily know how many of each type of element you need in order to balance it out. For example, potassium sulfide, or potassium and sulfur when they combine, maybe it's Ks, right? Maybe it's one potassium and one sulfur atom. Or maybe it's K2S, like we saw on the other page, which it actually is. But why is it K2S and not Ks2, or K2S3, or K3S5, right? There are an infinite number of combinations that we could use here. So why is it, what is it about potassium and sulfur that makes it K2S and none of the other ones? Well, we're going to take a look at that. Now, the first thing I need to point out is that this next strategy we're going to talk about is only valid for when we have an ionically bonded compound. So this only works when there's an ionic bond. Okay, that's the only time this works. So the stock system, what we're going to look at, only works when there's an ionic bond. But how do you know if the chemical bond is actually ionically bonded? Great, so hopefully you remembered that if there's a metal involved, so potassium, sodium, magnesium, any of those metals, if one of the metals is involved, then it's probably an ionic bond. And you can use the stock system to figure out how many of each atom you need. Now, the stock system itself is just a way of balancing the equation. So remember we talked about in class how these elements all want to be happy, and they're going to try to do that by either taking or giving away electrons. And remember we gave a special name for that, how much an atom wants to give or take, right? We called it the oxidation state, or the valence charge. So I'm going to use this kind of weird, funky skeleton, I call it a skeleton equation looking thing, where I have a line followed by parentheses plus a line followed by parentheses. And then the key part of this is that this whole thing equals 0. And I have this equaling 0 because this whole thing, the net charge of these ionic compounds, and that's key that this is an ionic compound, must equal 0, always and forever. Okay, now notice there are two parts to this. The first part of this guy, I have a line in parentheses, right? That's going to belong to the metal ion that I'm talking about. And the other side of this, the green here, this box, is going to be my nonmetal side of this. So an ionic bond is usually formed of a metal and a nonmetal. Okay, so really what this equation is telling us is that the total amount of charge from all of the metal ions has to be, when added together to the total charge of all of the nonmetal ions, has to equal 0, which is exactly what we've been talking about in class. Now, I've got these two parts for each of these, all right? In the metal, I have a line and parentheses. And in the nonmetal box, I have a line and parentheses, right? Well, I'm always going to put on the line the number of atoms or ions of the metal on the line. That's how many atoms I'm going to need. And the same thing is true for the nonmetal. I'm going to put the number of atoms or ions on the line. And I always do that in my skeleton equation so that I always know that whatever ends up, whatever number ends up there, that's got to be the number of atoms or ions of that particular element that I have. Okay? In parentheses, I'm always going to put the charge or the oxidation state of the metal. And on the other side, in the parentheses, I'm going to put the oxidation state of the nonmetal, so that the net charge is going to balance out. In other words, if I have two of a particular atom, so for example, if I have two sodium atoms, right? Well, that means I have a net metal ion of -2. Or I'm sorry, +2. I have two positive charges because I have two sodium atoms, right? Well, on the other side, I might only need one oxygen atom to balance that out. Or I might need something with a -2 charge. Or there are a couple of different options we're going to look at a little bit later. Okay, but for now, that's the basic structure. That's the idea of the stock system, to get all of the charges to balance out so that it turns out to be 0. So what I want you to do now is I want you to go ahead and I want you to read page 616 to 618 in your textbook. That gives you a nice visual for this and a different way of looking at it. And then once you're done that, you can go ahead and watch the next video where I'll go over an example with you of how to do this on page 2 of your packet. And then you can try a couple problems and check your answers in the front of the room. And then every page of this packet, I'm going to go through a different example with you to help you out. And I'm going to be going around the room like crazy, helping you guys out with anything you might need. Okay, so don't be afraid to come up and ask questions, but go ahead, do the reading, and make sure you take some notes on it, and best of luck.